Dead drops. Imagine two people working together for years without ever needing to stand in the same place at the same time. That is the trick behind a dead drop. One person leaves film, money, documents, or another small item. The other arrives later. No handshake, no conversation, not even a shared moment for surveillance to capture. For a brief period, the location itself becomes the intermediary. Intelligence services pushed this idea into almost absurd territory. CIA museum collections include hollow spikes, fake rocks, coins, and other objects designed to look so boring that the eye simply moves past them. In the Trigon operation in 1970s Moscow, dead drops in signal sites were used precisely because face-to-face meetings were considered too dangerous. A dead drop does not mainly hide the message, it hides the relationship between two people. But that safety costs time, and sometimes waiting is not an option. Live drops and brush passes. Sometimes the message has to move now. Not tonight, not tomorrow, now. And suddenly, the fastest method is also the most exposed. Two people have to be near each other. In its briefest form, a brush pass is a momentary handoff that can look, from the outside, like nothing more than ordinary movement in a crowd. The advantage is obvious. The package is not sitting somewhere for hours waiting to be discovered. The transfer happens, and the object is already gone. But now you have exactly what a dead drop was designed to eliminate: a shared moment. One frame, one point in time where sender and receiver exist together. For surveillance, that is valuable. Spy communication has an almost physical trade-off. The faster the exchange, the harder it is to hide the contact itself. And if even a few seconds together is too much, there is another option. Put a third person in between. Couriers and cutouts. Sometimes the safest line from person A to person B goes through person C. A courier moves material. A cutout does something more interesting. The intermediary breaks the direct relationship between the original source and the final recipient. Each person can see only a small piece of the chain. This is not just delivery, it is architecture built around not knowing. If one link is exposed, it does not automatically expose the entire network. Someone may know where to collect a package and where to pass it next without understanding who sits at the beginning or what happens at the end. That is why cutouts appear so often in descriptions of espionage tradecraft. Communication creates relationships. Relationships create patterns. A cutout breaks one large pattern into smaller ones. Of course, there is a price. More people mean more delay, more mistakes, and more points of failure. But the next step is stranger. What if communication does not need a human intermediary at all? Sometimes, one detail in the environment is enough. Recognition signals. Not every message needs words. Sometimes the entire message is basically yes or no. An object in a window, a small detail of clothing, some prearranged change in an otherwise ordinary scene. To everyone else, it is background. To one specific person, it is information. CIA accounts describe signal sites as a way to communicate very short states: ready or not ready, safe or unsafe, contact needed or contact canceled. It is almost one-bit communication embedded in the physical world. And here is the important distinction. The signal usually does not carry the secret itself. It controls another method. It can indicate that something has been left, that contact is needed, or that the next step should not happen at all. The strongest part of a signal like this is that an outsider has nothing to decode. They simply do not notice that communication happened. And if a tiny signal can disappear into ordinary scenery, why not hide an entire message inside an ordinary letter? Secret writing. You are looking at an ordinary letter, ordinary lines, ordinary paper, and possibly a second letter you cannot see at all. Secret writing, including invisible inks and related techniques, solved a different problem from encryption. It tried to hide not the meaning of the message, but the fact that another message existed on the page. The idea is far older than the Cold War. CIA histories trace American use of invisible ink back to George Washington's intelligence network during the Revolutionary War. Almost 2 centuries later, the same principle was still part of agent preparation. CIA material on Trigon specifically mentions training in secret writing before his return to Moscow. This gives us one of the most important splits in the entire map. Encryption says, yes, there is a message. You cannot read it. Secret writing says, What message? Then photography pushed that idea to an almost ridiculous extreme. Microdots. Take an entire page, shrink it, again, until the document is roughly the size of a printed period. That is a microdot. FBI artifacts show how strange this became in 20th century espionage. A photograph or document could be hidden where an ordinary inspection might see nothing more than a tiny mark. When the FBI investigated Rudolf Abel, agents found shortwave radios, cipher pads, cameras, and equipment for producing microdots among his espionage tools. And this is where one-time pads. This is the point where the communication channel no longer has to be secret. A one-time pad uses a secret random key once and only once. If that key is truly random, stays secret, and is never reused, the intercepted ciphertext by itself does not reveal one unique correct solution. The mathematics are fascinating, but for this story, the bigger idea is the separation of jobs. CIA museum collections include real, single-use encoder pads issued in matching sets, and Cold War case histories repeatedly place them alongside other agent communication equipment. Think about what changes. A letter can be opened. A radio transmission can be heard by thousands of people. That is no longer automatically catastrophic if the content has been transformed into groups that only the intended recipient can recover. The channel can be visible. The meaning stays private. And once you accept that, physical delivery is no longer mandatory. The message can travel through the air. Clandestine Radio. Radio removed distance from the equation and immediately created a new problem. During the Second World War, teams from the American Office of Strategic Services used compact radios to send intelligence from occupied territory back to Allied bases. A courier no longer had to physically cross the border. The information could cross it as a signal. But radio does not give you miracles for free. Receiving is quiet. Transmitting is not. When a device transmits, energy is leaving from somewhere. Historically, radio counterintelligence became a contest between two goals. One side needs enough time to communicate, the other wants to identify where that signal came from. That pressure drove spy radio toward shorter transmissions, one-way arrangements, and eventually burst systems. Radio did not kill dead drops or couriers, it simply took over the thing they handled worst: distance. And the strangest version of radio removes the recipient's reply entirely. Number stations. You turn the dial of a shortwave receiver, and through the static, a flat voice appears. 5, 7, 2, 9. More numbers. Then silence. The strange part is that the transmission is not trying to hide. Anyone can hear it. Number stations became a famous example of one-way shortwave communication, associated in public reporting and espionage cases with intelligence messaging. To an ordinary listener, groups of numbers or letters are meaningless. To a recipient holding the right key, they can carry instructions. The asymmetry is what makes the system so elegant. The sender transmits once, thousands can listen. One person needs to understand, and the recipient never has to transmit anything back. So the signal itself is completely public, while the meaning can remain private. But one-way communication has a price. What happens when the agent needs to send something back quickly? Short-range burst communications. By the late Cold War, the problem had changed again. How do you keep the speed of electronics without staying on the air long enough for the contact itself to become a problem? CIA records on Adolf Tolkachev describe a short-range agent communication system, or SRAC. Instead of a long voice exchange, compact devices could pass encrypted text in a brief electronic exchange. It was intended as an additional channel when a personal meeting was undesirable or an urgent message needed to move. And now the whole map comes together. A dead drop separates people in time. A cutout breaks the direct relationship. A signal shrinks communication almost to 1 bit. Secret writing and microdots hide the existence of the message. A one-time pad protects its meaning. Radio removes distance. A numbers station lets the recipient stay silent. Burst communication tries to compress the electronic contact itself. The technology keeps changing. The problem does not. How do two people exchange meaning without revealing the relationship between them?